Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today I'm going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so question 1 asks, how do you find the molar mass of sulfur hexafluoride? Okay, so the name of this compound is sulfur hexafluoride. Before. So to find out its chemical equation, it starts with sulfur, so that's just X. And then hexafluoride. So fluoride is from fluorine. And the hexa tells us that there are 6 fluorines in this compound. So to find the molar mass of sulfur hexafluoride, we would need both the molar masses of sulfur and fluoride. So their atomic masses can be found on the periodic table. So I'm just going to show molar mass of sulfur plus 6 times the molar mass of fluorine, since there are 6 atoms of fluorine in this compound. So the molar mass of sulfur is 32.07 grams per mole, and the molar mass of fluorine is 18.99. Okay, so adding up all these values, we end up getting a total molar mass of 146.05 grams per mole. Okay, so let's see what the junior tutor said. Sulfur hexafluoride is given by the chemical formula SF6. To calculate for the molar mass, we must multiply the atomic mass of each element and multiply it to the number of atoms present and add all the values. Sulfur hexafluoride consists of 1 atom of sulfur with an atomic mass of 32.065 and 6 atoms of fluorine with an atomic mass of 18.998. Calculating for the individual molar mass of each element will result in the following values. Yep, so they did the same math and ended up getting 146.053. Okay, so I can verify that this solution is correct. Okay, so moving on to question 2. Draw the major organic product of the following reaction. So here we have an alcohol group and a methyl group sticking out. And this reacts with HBr. So HBr is an example of a weak acid. And the compound that arises from this reaction is a brominated carbon group plus water. So the water came from the alcohol group that used to be on the compound. and it just got replaced with a bromine atom. Okay, so let's see what the junior tutor said. The given alcohol is reacted with a weak acid HBr. Since the alcohol is a secondary alcohol, then its product with HBr by SN1 or SN2 mechanism is given below. Yep, so this solution is correct. Okay, so on to question 3. What is the ionic compound formula of ammonium sulfate? Okay, so let's look at the compound name and identify the ions that are involved in ammonium sulfate. So ammonium is obviously the ammonium ion, which is NH4+, and the sulfate ion is an example of a polyatomic ion, and it has the formula SO4 2-. So since NH4 only has a +1 charge and the sulfate ion has a -2 charge, then we need 2 ions of the ammonium to neutralize the sulfate ion. So I'll just write ammonium in brackets to show that this whole ion needs to have 2 of them. And then I'll just write the sulfate right after. Okay, so this is the following ionic compound formula. Okay, so let's see what the junior tutor said. Ammonium sulfate is a compound formed by 2 polyatomic ions, which are sulfate ion and ammonium ion. Sulfate ion is SO4 2-, ammonium is NH4+. For ions to bond, the charges must be equal and opposite. Therefore, it will take +1 of 2 ammonium ions to balance the -2 of 1 sulfate ion. The formula for ammonium sulfate can be written as NH4 2SO4. Yep, so this solution is correct. Okay, so question 4, I believe. Yep, so question 4 just asks, what is the molar mass of calcium? So to find just an individual molar mass of a certain element, these are values that are given in the periodic table. In the case of calcium, it's simply just 40.08 grams per mole. Okay, so let's see what the junior tutor said. The molar mass of calcium is 40.078. Explanation: the molar mass is the mass of a given chemical element or chemical compound divided by the amount of substance, usually in terms of moles. The molar mass of any substance is numerically equal to the mass of that substance expressed in atomic mass units. The atomic mass units are easily found in the periodic tables. By looking at the periodic table, the molar mass of calcium is 40.078. Yep, so I can verify that this solution is correct. Okay, so on to question 5. How do you calculate the number of moles from volume? So first, let's recall the equation. concentration is equal to number of moles divided by volume. So concentration can be in moles per liter, number of moles is in mole, and volume is expressed in liters. So the short way of writing this equation out is simply just C equals N over V. So if we are given volume and we need to calculate the number of moles, we would simply just rearrange this equation to get number of moles is equal to concentration times volume. Okay, so let's see what the junior tutor said. The conversion of volume to the number of moles is only applicable to ideal gases under standard temperature and pressure. International Union of Pure and Applied Chemistry defined STP at a temperature of 273.15 Kelvin and an absolute pressure of exactly 100,000 pascals. At STP, 1 mole of gas occupies 22.4 liters of volume. To determine the number of moles of an ideal gas given its volume, we simply use the equation below. Okay, so this is what you would use for gases. I feel like this question meant for it to be in terms of a solution. So I'm going to say that this solution is correct, but I'm also going to add how to calculate number of moles from volume of a solution. Okay, so I said that this solution is correct for gases. However, if one wanted to calculate the number of moles from a volume of solution, the equation N equals CV can be used, where N is the number of moles, C is concentration of solution, and V is volume of the solution. Okay, so I just added that little note. Okay, so question 6 asks, what is the molar mass of zinc nitrate? Okay, so they gave us the chemical formula. And to calculate the molar mass, we need to know the different atomic masses of all of the atoms involved in the compound. Okay, so all of the atomic masses of the elements can be found on the periodic table. And to calculate for the molar mass of this compound, it's going to be the molar mass of zinc plus 2 times the molar mass of nitrogen. Since you can see the NO3 ion, there's 2 of them. And then finally, In NO3, there are 3 oxygen atoms, but again, there are 2 NO3 ions. So there are a total of 6 oxygens in zinc nitrate. So I'm going to multiply the molar mass of oxygen by 6. Okay, so now I can plug all their values in. The molar mass of zinc is 65.38 grams per mole. The molar mass of nitrogen is 14.01 grams per mole. And lastly, the molar mass of oxygen is 15.99 grams per mole. Okay, so adding up all these values, we end up getting a total molar mass of 189.38 grams per mole. Okay, so let's see what the junior tutor said. In definition, the molar mass is the mass of a given chemical element or chemical compound in grams, divided by the amount of substance in moles. The molar mass of a compound can be computed using a periodic table by adding the standard atomic masses of the individual atoms or elements. It is used to compute the number of moles of a certain compound to its given mass. To compute the molar mass of zinc nitrate, we need to get first the individual atomic masses of each element. Remember that for every 1 mole of zinc nitrate, there is 1 mole of zinc, 2 moles of nitrogen, and 6 moles of oxygen. Therefore, we need to multiply the atomic masses of zinc, nitrogen, and oxygen to 1, 2, and 6 respectively. Okay, so first they listed all the different atomic masses of zinc, nitrogen, and oxygen, and then they showed out all of the multiplication steps that needed to occur. And then lastly, they added up all these values together to also get 189.38. Okay, so I can verify that this solution is correct. Okay, so now let's move on to question number 7. Okay, so question 7 just asks, how do you convert grams to moles? So grams is a unit of mass, and moles is just its own unit. So to convert from grams to moles, we would simply just use the equation number of moles is equal to mass over molar mass. So step 1 would be to find the molar mass of the compound. So this is just using the values you would find on your periodic table. And then secondly, you would just use N equals mass over molar mass. Okay, so let's see what the junior tutor said. When converting grams to moles, we need to know the number of grams of the chemical compound and the molecular weight of the compound. For example, let us convert 100 grams of sodium hydroxide to moles. Step 1, find the molecular weight. So one sodium atom is 22.98 grams per mole. 1 oxygen, 15.99 grams per mole. 1 hydrogen, 1.01 grams per mole. The sum of all of these is the molecular weight of NaOH. So it has a molecular weight of around 40 grams per moles, and then use dimensional analysis. Okay, so the mass was 100 grams, and then they divided by the molar mass of NaOH to get 2.5 moles of sodium hydroxide. Okay, so I can verify that this solution is correct. It was also had a good example. Okay, so question 8 asks, how do you calculate the pH of HCl? Okay, so HCl is hydrochloric acid. And to help us understand how to answer this question, first I'm going to write hydrochloric acid as if its ions were dissociated in water. So breaking up HCl into its ions, you get a proton, which is H+, and also a chlorine ion. Okay, so once you know that this is what happens when HCl is dissociated into its ions, if a question gave us the concentration of HCl, we know that since this whole reaction is all 1 to 1 to 1, all of their concentrations will be equal to each other. So what's important for calculating the pH is knowing the concentration of protons that are dissociated in the solution. And this is important because in order to calculate the pH, this equation is actually negative log of the concentration of our H+. So if we know the concentration of HCl, we also know the concentration of the proton, and then we can calculate pH by taking the negative log of the concentration of the proton. Okay, so let's see what the junior tutor said. They said that the pH of HCl can be calculated by finding the value of the hydrogen ions present in the reaction. Since HCl is considered a strong acid, its dissociation can be represented as HCl makes H+ and Cl-, which shows a 1-to-1 molar ratio between HCl and H+. This will help you big time because most of the time the molarity of HCl is given in the problem. Because of the 1-to-1 molar ratio, we can say that the concentration of HCl is also equal to the concentration of protons in solution. If you determined already the concentration of hydrogen ions, you can now solve for the pH of HCl via pH is equal to negative log of the concentration of H+. Yep, so that was very well explained, and this solution is correct. Okay, so on to question 9. The density of silver is given as 10.5 grams per centimeter cubed. What is the volume in centimeter cubed of an ingot of silver with a mass of 0.443 kilograms? So this question gives us a lot of different variables, they give us density. So density is equal to 10.5 grams per centimeter cubed. We're looking for volume in centimeter cubed, and we are also given the mass, which is 0.443 kilograms. So if you notice, the mass is in units of kilograms, but the density is given in grams. So just to make everything the same units, I'm going to convert these kilograms to grams. So 0.443 kilograms is also 443 grams. Since there's 1,000 grams in 1 kilogram. Okay, so now that I converted my mass to grams, first let's recall the equation. Density is equal to mass over volume. So to rearrange and solve for volume, it's just going to be volume is equal to mass over density. Okay, so we are given both mass and density, so I'm just going to plug these values in. 443 grams over 10.5 grams per centimeter cubed. So you'll notice that our grams should cancel out, and our centimeter cubes goes from being in the denominator to the numerator. So we get a final answer of 42.19 centimeter cubed. Okay, so let's see what the junior tutor said. Density is defined as the measure of mass of a unit per volume of a material substance. Mathematically can be expressed as density equals mass over volume. It is commonly expressed in terms of gram per cubic centimeter. It can also be expressed as kilograms per cubic meter. To solve for the mass of a substance, given its mass and density, we can rearrange the formula. Now, solving for the volume of silver, we have 443 grams divided by 10.5 grams per centimeter cubed. Therefore, the volume of silver is 42.19 centimeter cubed. Yep, so this solution is correct. Okay, so on to question 10. Just asks, calculate the formula mass of dinitrogen monoxide. So formula mass is the same thing as molar mass. To find the molar mass of dinitrogen monoxide, we would need the atomic masses of both nitrogen and oxygen. So I'm going to multiply the atomic mass of nitrogen by 2, since there are 2 atoms of nitrogen in the compound. Then I'm just going to add this with the molar mass of oxygen. So the molar mass of nitrogen can be found on the periodic table. It's just 14.01 grams per mole. And the molar mass of oxygen is 15.99 grams per mole. Okay, so adding these values up, we end up getting 44.01 grams per mole. Okay, so let's see what the junior tutor said. Relative formula mass has the symbol MR to calculate the MR. To calculate the MR for a substance, step 1, work out how many atoms of each element there are in the chemical formula. Step 2, add together the AR values for all the atoms of each element present. So AR stands for the relative atomic mass. So to calculate formula mass for dinitrogen monoxide, we have to know the AR values. Nitrogen is 14, oxygen 16. And then they showed the multiplying it out. And then the last step is to add 28 plus 16 to get 44. Yep, so this solution is correct. Okay, so question 11 asks, oxygen gas is always written as O2 in chemical equations. What term is used to describe the 2 in the formula? So the 2 is called a subscript. So subscripts tell us how many atoms are in the compound. Okay, so let's see what the junior tutor said. The 2 in the formula is the subscript. Subscripts in the chemical formula tell how many atoms of the specific element are involved in the production of the particle, molecule, ion, or compound. Oxygen gas is a diatomic molecule. 2 atoms of oxygen have to bond with each other to form an oxygen gas molecule. Yep, so this solution is correct. Pretty straightforward. Okay, so on to question 12. Is acetic acid a weak acid or a strong acid? So the formula for acetic acid is CH3COOH. So just quickly summarizing the difference between a weak acid and a strong acid is that a weak acid does not dissociate into its ions easily. So in the case of acetic acid, it is a weak acid. So I'm going to show this, and then I'll also show that it is less likely for the acetic acid to dissociate into its ions, which is H plus and CH3COO minus. So on the other hand, we can have a strong acid. So strong acids are able to dissociate into their ions readily. So an example of a strong acid is simply just hydrochloric acid. So I'm going to show the arrows. And it can easily dissociate into H plus and Cl minus. Okay, so the junior tutor said acetic acid, CH3COOH, is a weak acid because it is present in a solution primarily as whole CH3COOH molecules and very little as H plus and acetate ions. Yep, so this solution is correct. Okay, so I said the solution is correct. Weak acids do not readily dissociate into their ions. Strong acids, on the other hand, such as HCl, can dissociate into their ions readily in solution. Okay, so question 13 asks, what is an example of a redox reaction? So a redox reaction, as you can guess by the name, it involves a compound getting reduced and a compound getting oxidized. I'm just gonna write that general definition down. And this happens because of the transfer of electrons. So I'll say this occurs through electron transfer. So when you have a reduction reaction, then that element gained an electron. And when you have an oxidation reaction, then that element lost an electron. And there are two ways that people try to remember which reaction is gaining an electron and which reaction loses an electron. And the one way is by using oil rig. So oxidation is losing and reduction is gaining. Or you can do Leo-Gur. So losing electrons is oxidation and gaining electrons is reduction. Okay, so that's what that means. So I'll just write down an example of a redox reaction down here. So let's say we had iron plus oxygen makes an iron oxide. Okay, so let me balance this equation out. Okay. So this is an example of a complete redox reaction. Let's say we had our oxygen, which goes from an oxidation number of 0. And then when it is in the compound, it goes to an oxidation number of -2. In the case of the iron, it goes from an oxidation number of 0 to an oxidation number of +3. So when the oxidation number increases, this is showing the element getting oxidized. So I'm just going to add that definition here. And when the oxidation number decreases, that means the atom got reduced. Okay, so I'm going to separate this redox reaction into the two half reactions. So that just means I'm going to separate and show the reduction reaction. And then I'm going to show the oxidation reaction. Okay, so let's see what the junior tutor said. A redox reaction or oxidation reduction reaction are electron transfer reactions. That is, there will be a loss or gain of electrons in the reaction. An example of this would be zinc solid plus lead sulfate makes zinc sulfate plus lead solid. The zinc reduces the lead 2+ to just lead 0, and zinc is in turn oxidized to zinc 2+. Yep, so this solution is correct. Okay, so question 14 just asks, what is the molar mass of zinc? So the different molar masses of individual elements can be found on the periodic table. In the case of zinc, it is 65.38 grams per mole. So the junior tutor said the molar mass of an element is the same as its atomic mass. This can be easily seen in the periodic table. Molar mass of zinc with the chemical symbol Zn is equal to 65.38 grams per mole. Okay, so the junior tutor also had a periodic table of elements attached to the answer. So zinc can be seen here, and its atomic mass is right below the chemical symbol. So it's the smaller font that you can't really read right now. So don't get confused with the mass number by the atomic number for zinc. So atomic numbers are found on the top left of each of their individual boxes. So the atomic number of zinc is 30, so that means it has 30 protons. And its atomic mass is the number at the bottom here, so it's the 65.38. Okay, so I'm going to say that this solution is correct. Okay, so now we are moving on to question 15. How do you determine the molar mass of heptane? Okay, so let's pretend like we don't know the chemical formula for heptane. So let's try to analyze the name. So it has a prefix of hept, which tells us that there are 7 carbons in the parent chain. And the fact that it ends in ane just tells us that there are all single bonds involved. Or only single bonds involved. So if this compound ended in ene, we'd know that there would be a double bond. If it ended in ine, then we know that there is a triple bond. So since heptane only ends in ane, then there are only single bonds involved. So now I can draw out 7 carbons to make a chain. And since carbon can have 4 bonds attached to it, I'm going to fill out the rest of them with hydrogens. So now that I have the long chain of heptane, I can figure out its chemical formula. So it'll just be C7H16. Okay, so now that I know how many atoms of carbon and hydrogen are in heptane, I can calculate its molar mass. So it's going to be 7 times the molar mass of carbon, since there are 7 atoms of carbon, and then 16 times the molar mass of hydrogen. Again, these individual atomic masses can be found on the periodic table. For carbon, it is just 12.01 grams per mole. And for hydrogen, it is 1.01 grams per mole. Okay, so adding these values up, we get a total of 100.21 grams per mole. Okay, so let's see what the junior tutor said. The molar mass of a substance is the sum of the molar masses of all the atoms in the substance. For heptane, with a molecular formula of C7H16, the molar mass is the sum of the molar masses of all carbon and hydrogen atoms, which are 12.01 and 1.008 grams per mole respectively. Calculation is shown below. Yep, so they also got 100.205, so this solution is correct. Okay, so on to question 16. How is Q equal MC delta T used? What does each variable represent? What are the units of the variable? How does it work? Okay, so I'll break down all of the units and all the variables. So Q represents the heat transferred. In the reaction. And it can have a units of joules or kilojoules, and you need to convert to joules. But basically, it could be given in your question. M is for mass. And typically it is given in kilograms or grams. C stands for the specific heat capacity. And its units are in joules divided by grams times degrees Celsius. And finally, delta T resembles the change in temperature. So delta T can also be written as delta T equals T final minus T initial. So a question might give you the temperature at the beginning of the reaction and the temperature at the end. So the difference between the two would just be the change in temperature. And this is in degrees Celsius, or it might be given in Kelvin. So it all depends on the units for the specific heat capacity. So if they give you the units in joules over grams times degrees Celsius, then we would need to convert kelvins to degrees Celsius, convert kilograms to grams, and convert kilojoules to joules, just so that everything is in the same units. Okay, so let's see what the junior tutor said. The equation Q equals MC delta T represents the amount of heat supplied to a given object with a mass and specific heat capacity multiplied to the change in temperature delta T it causes. The specific heat capacity is an intensive property of a material which is defined as the amount of heat energy required to raise its temperature by 1 Kelvin or 1 degree Celsius. Q equals the amount of heat transferred. Mass of the object is M. C is the specific heat capacity. Delta T is the change in temperature. Yep, so this solution is correct. Okay, question 17 asks, what is the ionic compound formula of aluminum chloride? Okay, so let's look at aluminum chloride's different ions. So aluminum, its ion is Al3+, and a chlorine ion is Cl-. So since aluminum has a +3 charge, we need 3 chlorine ions to neutralize the aluminum. So this ionic compound formula would just be AlCl3. Okay, so the junior tutor said aluminum chloride is a compound formed by two polyatomic ions. Not really polyatomic, but which are aluminum and chloride. For ions to bond, the charges must be equal and opposite. Therefore, it will take -1 of 3 chloride ions to balance the +3 of 1 aluminum ion. Formula of aluminum chloride is AlCl3. Okay, so question 18 asks, the net charge on a sulfide ion is -2. How does this ion obtain its charge? Okay, so let's just look at a sulfur atom. It has a total of 16 electrons. So let me draw out its electron diagram and show how all the electrons would be shown. Okay, so if we look at the outer ring of a sulfur atom, you'll see that there are 6 valence electrons. So there are 6 electrons in the outer ring. And in order to gain a full octet, to be more stable, it needs 2 electrons to gain a full octet. So this is where the -2 comes from. Since electrons are negatively charged, if you gain 2 of them, then the sulfur ion will have a -2 charge. Okay, so the junior tutor said, sulfide ion is an atom of sulfur that gains 2 electrons from some element, else or molecule or compound. I'll just draw those in. Gaining an electron/electrons will result in the formation of a negatively charged ion or anion. On the other hand, losing electrons will result in the formation of a positively charged ion or cation. Yep, so the solution is correct. Okay, so we have time for one more question. 19. How do you find the number of protons and neutrons and electrons of a particular atom? All you're given is the atomic number and the mass number. Okay, so let's recall that the atomic number is equal to the number of protons. So that's already kind of given. And let's also recall that the mass number is equal to the number of protons plus the number of neutrons. So since we know the number of protons from the atomic number, In order to solve for the number of neutrons, it would just be the mass number minus the atomic number. And lastly, for number of electrons, if the atom is neutral, then the number of protons would be equal to the number of electrons. Since protons have a +1 charge and electrons have a -1 charge. Okay, so the junior tutor said the periodic table of elements is really helpful in identifying many properties of an element, which includes the number of subatomic particles it has. One simple representation of an element in the periodic table, such as oxygen, is shown in the figure below. There are two numbers in this example. The upper right represents the mass number of the element, while the lower number represents the element number in the periodic table. Atomic mass number represents the number of neutrons and protons present in the atom. The element number represents the number of protons in the atom. Thus, the number of protons can be easily identified. Number of neutrons, subtract the atomic mass number to the element number. Yep, so I'm just going to add how you would calculate the number of electrons. Okay, so I said if we wanted to also calculate the number of electrons in a neutral atom, it would be equal to the number of protons. Okay, so that is all we have time for today's session. And if you like today's Q&A and you'd like to be notified of when we do this next, then please hit the subscribe button and the notification bell below. If you'd like to submit a question of your own, then check out the links in the description. And also don't forget to leave a like and a comment if you enjoyed today's video. Don't forget to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.